So what have we got here? Well, what we've got is a spark plug ceramic, and we've got a centre electrode, 20 to 40 kilovolts of electrical energy in there. We've got a ground electrode here, and we have a spark jump in a gap. Why am I showing you a spark plug when I'm talking about ground problems on backlights of vehicles? Well, I think it's very important to show you this because I'm going to show you a couple of connectors in a minute. So what we have essentially is we have a spark up to 40 kilovolts in some cases, and it's jumping this gap. But why is it jumping that gap? Well, it's jumping it because electricity, with such power behind it, 40 kilovolts, it's huge amount of voltage. It can jump that gap. That's the whole point of a spark plug. The laws of physics. It's like lightning. It will jump that gap quite easily. And then it'll go to ground. In fact, it looks like it's coming from the ground at first under a 25,000 frame per second video. But that's something for another day. The reason I'm showing this can happen. This spark plug jumping the gap where the electricity can sort of, it's an arc, isn't it? It's an electrical arc. It's an artificially induced arc. You're basically creating artificial lightning, let's be honest. That's what you're doing. Connectors can have the same issue. So if you imagine this is a connector, and I'll flash it up on the screen in a second. This is controlled arcing. This is fine. This is okay. But on a connector, it is not controlled. So that's a controlled arc. We're alright with that. We use that to ignite petrol in a cylinder. But on a connector, I'm going to show you now, it's uncontrolled arcing what causes a lot of problems and ultimately melted connectors. Right, before we get into diagnostics, I need to clear something up that confuses a lot of people, and that is something called electron flow. In reality, in actual physics, electricity is the movement of electrons, and electrons are negatively charged. So in a circuit, electrons physically move from negative to positive. That happens because the negative terminal has an excess of these electrons, and the positive terminal has a deficit of electrons. Nature hates imbalance. So these electrons are attracted across the circuit towards the positive side. Now, this movement only happens because there is a potential difference, in other words, electrical pressure between the two terminals.
I am so attracted to you, Pete. I can't stop these electrons flowing.
No potential difference equals no movement. Now, here's where things get interesting. Back in the 1800s, long before electrons were properly understood, engineers guessed the flow direction wrong. They assumed current flowed from positive to negative. And by the time we had discovered electrons and realised the flow was actually negative to positive, it was already too late. Every diagram and every standard and every textbook was already written. So electron flow is the real physics, negative to positive, but for diagnostics, diagrams and testing, and this video here, we're going to use the other one. And that's what we'll cover next. So here's the conventional diagram. This is the standard that we use today. We've got a battery, a positive cable going to a bulb. Then we have a negative cable coming out of the bulb across a fuse and into the negative terminal of the battery. Now, in reality, you would actually have a fuse on the positive side, but this is AI, and basically I get what I get when I come to do the images. I'm not an artist. I just get what I can get from Nano Banana Pro, and this is what it came up with. So in reality, of course, you'd have the fuse on the positive side, but don't shoot me for that. I'm only trying to teach a theory. So we're going to have 12 volts on that positive cable, we're going to have a drop over the bulb, and we're going to have 0 volts on the ground, back to the battery, and we're going to continue in a loop, ad infinitum until the battery runs out of juice. That's how we teach modern electrics. That's the flow that we're going to use within this video.
As you can see here, when the ground path fails, the current backfeeds through the other bulb, causing this classic alternating pattern and voltage drop.
What you're looking at on the screen here is not an open circuit. This is a circuit with a high resistance ground. Power leaves the battery, goes through the fuse, goes through the bulb, and the bulb does light. But notice what happens after the bulb. Because the ground point has corrosion and resistance in it, the voltage cannot return to the battery properly. So instead of dropping back to near 0 volts, we're left with several volts of positive potential sitting on the ground side of the circuit, in this case 8 volts. In this example, the bulb only drops part of the system voltage, the remaining voltage has nowhere to go. It just floats and sits there waiting for a path. Now here's where the strange behaviour starts. Inside a real lamp unit, that wire isn't isolated, it's electrically connected to other bulbs through filaments and internal wiring. So that leftover voltage can pass backwards through another bulb, and then use that bulb's ground as its return path to the battery. That's why on cars with bad earths, old Renaults, Citroens, anything with tired wiring, you press the brake pedal and the side lights glow, or the fog light comes on dim. The brake light hasn't magically powered them, it's borrowed their ground. The circuit is still complete, just in completely the wrong way. Once that ground opens fully, everything stops. But until then, electricity will always find some way home. The really simple circuit, just to get everyone on the same page. We've got a 12 volt battery here. We've got a bulb as the load. And down here we've got an open circuit on the ground side. Basically the return path is broken. There's no complete route back to the battery, so the bulb can't light. Now, this is where a lot of people get confused. Even though this circuit is open and nothing is flowing, you'd still measure 12 volts. And you would measure it at the bulb on the ground side of the bulb as well as the positive side. Now, it all sounds impossible until you understand exactly what's happening. Let's get some arrows on. So conventional automotive teaching will have us understand that we've got some electrical pressure here, voltage, 12 volts as it happens, and we have current flow, and we need for the current to flow. We can always have voltage, but we will never have current if the two poles of the battery are not connected to each other. Well, if you connect them, they'll set on fire. So you always need a load in between, but you do need this load to complete a circuit, because we can have electrical pressure voltage here. All day long you can have electrical pressure, it's just flowing, it just sits there. But in order for the magic to happen, we need current, well, we need a ground return for that to happen, and it can't return because of the open circuit, you see. Now then, why do we see 12 volts? Well, first of all, we've got 12 volts. We've got 12 volts here. We'd even have 12 volts here, won't we? So far, so good. But what about the ground? Well, this is where it gets extremely interesting, and for many years as a young man, I never understood why I had 12 volts on the ground. Why have I got 12 volts on the ground? 12 volts. It's a bit off the page there, but never mind. And why have I got, after the break, 0 volts? 0 volts. And right at the battery, rightly so, 0 volts. That's our circuit, our faulty circuit. Why? Well, as I said, voltage is electrical pressure. And that pressure from the positive terminal is still being applied all the way down here. And it's still being applied up to the red wire into the bulb. But because the ground is broken here, there is no return path, no loop, so no current can flow. Remember, it should be flowing in one complete circuit like this. Just like a big merry-go-round. In, out, in, out, in, out. Well, we've got an open circuit, so we've no current flow. But here's the thing. The pressure still reaches this load from here, the voltage, the electrical pressure. So everything from the battery positive through the red wire into the bulb, and then right at the point of that break, that all floats up to 12 volts. So it's a float, and that includes the so-called negative side of the bulb as well. It all sits at battery positive potential because nothing's moving. Past the break, as I said, everything will drop back to 0 volts because that side is physically actually connected to the battery negative, whereas this side's connected, there is no negative. It's not connected to the chassis ground at all, is it? Because you don't have one. In reality, it would have some chassis ground, it wouldn't go direct at battery, but still, either way, if it's broke, it's broke. Job done, you've no ground. So when you probe around a broken ground circuit and you see 12 volts here or here, and then you see 0, you know you've got a break somewhere in that circuit. You just need to find it. You can always bypass it, and that's partly what this video is about as well. If it's a physical fault with, like in this video, the light cluster, there's ways around it which you're going to see. All it means is that the circuit's pressurized, but it's open. So you've got voltage, you've got pressure, but you've no current flow, and that's why the bulb stays off. And here's a final diagram for you. There's our positive probe. We're doing a voltage drop test from negative to negative. And essentially we've got our 12 volt there, essentially, instead of 0. And the reason we've got that is because we've no ground return path. And there's our lovely electrons, negatively charged, sat there. They can't go anywhere. They're basically just electrical pressure, there's voltage. and they're going to sit there because they have no return path. And here's the number one failure I see all the time: a completely melted ground at a rear light. You've got no light operation at all, unlike our previous couple of images. We've got a completely blank light, nothing on the light works if it all shares a common ground, and essentially it needs a new lamp cluster, and crucially to replace the pin, because the pin spreading and arcing is what's caused this to overheat in the first place. For more advanced fault finding tips like these, make sure you hit the subscribe button, and I'll see you in the next video.